So suppose they're asking any kind of parameters for this kind of network. Don't worry, just follow same procedure as usual. Okay. So for example, for this problem, they're asking for obtain z parameters. Right. So please don't compromise the way you're allocating V1 I1 and V2 I2. So since the two-port network parameters are V1, the variables are V1, I1, V2, and I2. So for the top one, you can take the another current, that is I3. Okay. Or you can go with the interconnection of two-port networks. So it's a better thing. Okay. You can do very easy. Nothing is there. Fine. So apply KVL for input port. Okay. Minus V1, 2 into, so I1 orientation, then I3 orientation, opposite with each other, I1 minus I3, and then 2 into I1 plus I2 equal to 0. So by organizing this thing, V1 equal to 2I1 plus 2I1, 4I1 plus 2I2 minus 2I3. Okay. Now you can go to second port or output port, apply. So minus V2. You look at this 2 ohm, the current direction of I2 will be like this. I3 is coming like this, right? Okay. So 2 into I2 plus I3 plus 2 into I2 plus I1 equal to 0. So organize this thing. V2 equal to 2I1, 4I2 plus 2I3. Let it be. Now you can apply KVL for the top mesh. Okay. So how can I write for this thing? 2 into I3 regarding to this thing. I2 orientation, I3 orientation, 2 into I3 plus I2. So regarding to this 2 ohm, I3 minus, so 6I3, 2I2, 6I3 equal to I3 equal to 1 by 3 I1 minus 1 by 3. So it denotes that you can represent the corresponding I3 in terms of I1 as well as I2. So now I'm going to place it in the both equations where V1 equal to 4I1 plus 2I2 minus 2I3. So V1 equal to 4I1 plus 2I2 minus 2 by 3 I1 plus 2 by 3 I2. So organize this thing. 4 minus 2 by 3, 10 by 3 I1, I2, 8 by 3. And then from the second equation, V2 equal to 2I1 plus 4I2 plus 2I3. So V2 is nothing but 2I1 plus 4I2. So instead of I3, I would like to replace 1 by 3 I1 minus 1 by 3 I2. So organize this thing. 2I1, 2 by 3 I1, and then 4I2 minus 2 by 3 I2. So 2 plus 2 by 3, 3 2s are 6, 6 plus 2 8, 8 over 3 I1, and then 4 3s are 12, 12 minus 2 10, 10 by 3 I2. Now for looking equation number 3 and 4, it is in terms of V1, I1, V2 and I2, the generalized Z parameters of two-port network. So by making the comparison, the value of Z11 is nothing but 10 by 3 ohm. The value of Z12 is nothing but 8 by 3 ohm. The value of Z21 is nothing but 8 by 3 ohm. The value of Z22 is nothing but 10 by 3 ohm. Okay. So now you can make the comparison for reciprocal and symmetrical. Z11 and Z22 equal with each other. Symmetrical. For reciprocal, the value is nothing but so the given network is belongs to reciprocal as well as symmetrical. Okay. So we're going to discuss about how to find the impedance parameters, and we're going to check it about whether the network is belongs to symmetrical or reciprocal by satisfying the corresponding conditions. Okay. So it's a given two-port network. Assign V1, I1, V2, I2. So apply KVL for input port. So how can we write this thing? Minus V1, 2 into I1, 7 into I1 plus I2 equal to 0. V1 equal to 9I1 plus 7I2. Now I can go to the port number 2. Port number 2 minus V2 plus 7 into I2 plus I1 equal to 0. V2 equal to 7I1 plus 7I2. So this is the corresponding KVL equation of the input port as well as output port. Okay. So we know the generalized impedance parameters of two-port network. So where Z11 is belongs to input impedance, Z12 is belongs to transfer impedance from port number 1 to port number 2. Z21 belongs to transfer impedance from port number 2 to port number 1. Z22 belongs to output impedance. Now make the comparison of both the equations. So Z11 is nothing but 9 ohm. Z12 is nothing but 7 ohm. Z21 is nothing but 7 ohm. Z22 is nothing but 7 ohm. Okay. So now they're asking for whether the network is belongs to reciprocal or symmetrical. Okay. So in the case of reciprocal for a two-port network, by using Z parameters, the required condition, the transfer impedance is equal with each other. So here, so this belongs to reciprocal. And then if you want to say the corresponding two-port network is belongs to symmetrical, the required condition Z11 equal to Z22. So the value of Z11 9 ohm, Z22 7 ohm, both are not equal here. So it is belongs to non-symmetrical. Okay. So you can conclude that the corresponding two-port network belongs to reciprocal but not symmetrical. Okay. Okay. So in today's class, we're going to discuss about how to find Z parameters of the given two-port network. Okay. So first, you have to mark the corresponding input voltage, output voltage, input current, and output current. Okay. So the given network is belongs to T network. It is more convenient to write the KVL equation to find Z parameters. Okay. So now I'm going to derive the respective Z parameters of the given network. So apply KVL for input port. So minus V1 plus 2 into I1 plus 3 into I1 plus I2 equal to 0. So V1 equal to 5 into I1 plus 3 I2. So corresponding KVL equation of port number 1. So apply KVL for port 2 or output 1, no problem about that. So minus V2, then 4I2 plus 3 into I2 plus I1 equal to 0. So V2 equal to 3I1 plus 7I2. So we know that the generalized two-port network impedance parameters. So V1 equal to Z11 I1 plus Z12 I2, Z21 I1 plus Z22 I2. Now you can make the comparison with the first equation. So you can able to derive that Z11 equal to 5 ohm, Z12 equal to 3 ohm. From the second equation, V2 equal to Z21 I1 plus Z22 I2, Z21 equal to 3 ohm. So 5 ohm, 3 ohm. So in this class, we're going to discuss about how to determine the Y parameters of given two-port network. Okay. So by looking at the given two-port network, it is belongs to pi network. For pi network, it is very easy to write KCL equation, and you can determine Y parameters very easily and convenient. Okay. So in the case of T network, we are applying KVL to determine the Z parameters. In the case of pi network, we are going to apply KCL to obtain the Y parameters very easily. So according to KCL, sum of entering current at a node equal to sum of leaving currents away from the node. Okay. The corresponding node voltage V1, the corresponding node voltage V2. So if we're checking at node number 1, the corresponding resistors are 2 ohm, another one 2 ohm is connected between node 1 and node 2. So where I1 is going to be the entering current at the node 1. Okay. So apply KCL at node 1. Okay. So the corresponding current I1, sum of entering current equal to sum of leaving currents from the node. Okay. V1 divided by 2, V1 minus V2 divided by 2. So organize this thing, 1 over 2 and 1 over 2. Now This is the corresponding KCL equation at node number 1. Now we're going to write the corresponding KCL equation at the node number 2. So the corresponding entering current at node 2 is I2. Apply. So the entering current I2, node 2 voltage V2 divided by 2 ohm, V2 minus V1 by 2 ohm. So organize this thing. I2 equal to minus V1 by 2, V2 into 1 by 2 plus 1 by 2. Now we're having the corresponding node equations at the node number 1 and node number 2. The generalized y parameters y11 v1, y12 v2, I2 equal to y21 v1 plus. So now I can take the first equation where I1 equal to v1 minus 1 by 2 v2. So by comparing this thing, y11 is nothing but 1 mho y12 minus 1 by 2 mho. And then you take the second equation where I2 equal to y21 v1 plus y22 v2, y21 y22. So the corresponding admittance matrix for the two-port network. So the required condition to say the corresponding two-port network belongs to reciprocal by using y parameters y12 equal to y21 in the case of reciprocal. In the case of symmetrical, now you can make the comparison. So the value of y12 is nothing but negative 1 by 2 mho, and the value of y21 also same negative 1 by 2 mho. So the network is belongs to reciprocal. And then now you can make the comparison of y11 where it is nothing but 1 mho. So the corresponding given two-port network is belongs to symmetrical as well as reciprocal. ABCD parameters are T parameters. Okay. So now we are going to determine the corresponding ABCD parameters of the following two-port network. So again, it is belongs to T-type network. Okay. So for T-type network, apply KVL equation irrespective of the required parameters. Either it may be ABCD parameters or H, whatever it may be. So in the case of T network, the much convenient thing is Z parameters, but still to determine ABCD parameters also, you can do the conversion or do the things. Okay. You need not remember any kind of formulas here. Don't compromise the way you are going to mark the polarities of V1, the directions for I1 and I2. Okay. So now I'm going to write KVL equation for input port. So minus V1, 2 into I1, 4 into I1 plus I2 equal to 0. So organize this thing. 2 plus 4, 6 I1 plus 4 I2. So let it be first equation. So the corresponding KVL for the input port. Similarly, you can write the KVL equation for the output port. So minus V2 plus 2 into I2 4 into I2 plus I1 equal to 0. So organize this thing. V2 equal to 6I2 okay. So this is the corresponding KVL equation of input port and output port. So the generalized ABCD parameters V1 equal to AV2 minus BI2, I1 equal to CV2 minus DI2. So to determine the value of A is nothing but V1 by V2, where the output port current will be 0. Let's make it as open circuit. Okay. So when I2 equal to 0 from the both the equations, so V1 equal to, we'll get 6 into I1 from first equation. Similarly from second one, by placing I2 equal to 0, V2 equal to 4 times I1, V1 by V2. Okay. Similarly, by taking the condition I2 equal to 0, we can determine the another one C also. So where C is nothing but the ratio between I1 to V2, where I2 equal to 0. So when I2 equal to 0, from second one, V2 equal to 4 into I1. We require I1 by V2. So where C equal to, similar, the remaining two, that is nothing but B and D. To determine B, minus V1 by I2, where V2 equal to 0. So when V2 equal to 0, from the second one, just check the second equation. So when V2 equal to 0, that's nothing but 4I1 plus 6I2 equal to 0. 4I1 plus 6I2. So I1 equal to, so place it in the first equation. Okay. So the first equation is nothing but V1 equal to 6I1 plus 4I2. So where I1 is nothing but minus 3 by 2 I2. So we require minus V1 by I2. So that is nothing but B. Okay. So the another one, D. D is nothing but minus I1 by I2, where V2 equal to 0. So when V2 equal to 0, from the second one, 4I1 plus 6I2 minus I1 by I2. 3 by 2, right? So the value of D. Okay. So to say the corresponding two-port network is belongs to a reciprocal by using ABCD parameters, the required condition delta T equal to 1. If you want to say the corresponding two-port network belongs to symmetrical by using ABCD parameters, where A equal to D. So now we're having the corresponding T parameters are the value of A, that is nothing but 3 by 2, D 3 by 2, the value of B 5, and the value of C is 1 by 4. So now we can make the comparison. The value of A is nothing but 3 by 2. D also 3 by 2. So this belongs to symmetrical. Now we'll determine delta T, where delta T is nothing but 3 by 2, 5, 1 by 4, and 3 by 2, 9 by 4 minus 5 by 4. So delta T equal to 1. So it belongs to reciprocal, right? So far we discussed about Z parameters, Y parameters, hybrid parameters, and ABCD parameters. In glance, the corresponding conditions for symmetrical and reciprocal also visited by using each and every parameter. Okay. So now we are going to obtain hybrid parameters of the given two-port network. So here, the corresponding given network belongs to T network. So first you assign the two-port network parameters, that is V1, V2, I1, I2. So where V1 belongs to input port voltage, V2 belongs to output port voltage, I1 belongs to input port current, I2 belongs to output port current. Okay. So here, irrespective of any parameters like H parameters or A, B, C, D, or Y, whatever it may be, if the given network belongs to T network, so without any doubt, you can write first KVL equation. Okay. Then you can determine whatever you require here. So apply KVL for the input port. So how can we write this thing? Minus V1 plus 3 into I1, 6 into I1 plus I2 equal to 0. So V1 equal to 3I1 plus 6I1 plus 6I2. V1 equal to 9I1. So this is the corresponding KVL equation of the input port. Okay. Now apply KVL for output port. Okay. So the corresponding output port voltage minus V2 plus 3 into I2 plus 6 into I2 plus I1 equal to 0, where V2 equal to 3I2 plus 6I2 plus 6I1, where V2 equal to 6I1 plus 9I2. So this is the corresponding KVL equations of port number 1 and port number 2, right? So the generalized hybrid parameters V1 equal to H11 I1 plus H12 V2. Okay. So now the given network belongs to T network. We are writing the KVL equations. This is generalized equation we are getting 1 and 2. Now to determine H11, V1 divided by I1, where V2 equal to 0. So this is nothing but input impedance. Since V1 belongs to input port voltage, I1 belongs to input port current by short circuiting the output port. Okay, fine. So what's the condition here? When V2 equal to 0, by plugging into equation number 1 and 2 from equation number 2, when V2 equal to 0, 6I1 plus 9I2 equal to 0. 9I2 equal to a negative 6I1. I2 equal to minus 2 by 3 I1. Place it in the first equation. Okay. So in first equation, V1 equal to 9I1 plus 6I2. 9 into I1. Instead of I2, I'm going to replace with minus 2 by 3 into I1. 9I1 minus 4I1. 3 ones are 3 twos are okay. 2 into 2, 4. Okay. Plus into minus, minus. So V1 equal to 5I1. V1 by I1 is nothing but. So where H11 equal to V1 by I1, where V2 equal to 0, that is nothing but 5 ohm. So by taking the same condition V2 equal to 0, you can determine H21 also. Okay. So where H21 is nothing but forward current gain. Okay. I2 divided by I1, where V2 equal to 0. So by placing V2 equal to 0 from the second equation, from second one, V2 equal to 0. So 0 equal to 6I1 plus 9I2. So we require here the ratio between I2 to I1, right? I2 by I1 equal to. So H21 equal to. Clear? Okay. And then to determine H12, V1 by V2, where I1 equal to 0. So by placing I1 equal to 0 from equation number 1 and equation number 2, so V1 equal to 6I2 and then V2 equal to 9I2, V1 by V2. So H12 equal to 2 by 3. So where H12 is called as reverse voltage gain. Okay. Where H21 is called as forward current gain. Okay. Forward current gain. Similarly, H11 is belongs to input impedance. And the last thing, H22, right? So where H22 is nothing but output admittance I2 by V2, where I1 equal to 0. When I1 equal to 0 from second one, so V2 equal to 9 into I2, I2 by V2. So H22 equal to this nothing but output admittance. Okay. Output admittance. So now we are having the values of H11, H12 and H21 and H22. So the corresponding hybrid parameters of two-port network, the given thing. H11 is 5 ohm, H12 2 by 3, H21 negative 2 by 3, and then H22. So the corresponding condition of a two-port network is said to be reciprocal by using hybrid parameters. H12 equal to minus H21 in the case of reciprocal. In the case of symmetrical, delta H equal to 1, that is modulus. We'll check those things. So here the value of H12 is nothing but 2 by 3. H21 is nothing but negative 2 by 3. So we observe that it is satisfying the condition H12 equal to minus H21. So the given two-port network is belongs to reciprocal. Okay. Now we'll check for the delta H. Okay. So H11 value 5 ohm, and then H12, H21, and then H22 5 by 9 plus 4 by 9. So delta H equal to 1. So it is belongs to symmetrical as well as reciprocal.